Hello guys, you're welcome to this YouTube channel. Please, I would like you to subscribe to this YouTube channel and hit the notification bell to get updated each time we upload a video. Alright, today we'll be looking at a randomized completely block design. Randomized completely block design. Please, in case you have not watched my video on completely randomized design, please you can check it. That was the recent video I made, completely randomized design. So now in statistical analysis of variance, we're going to be looking at the block design. Now the block design is also commonly known as two-way ANOVA, where you are given there are some values to find, and you have to find some parameters from your table. So now you are given a table to compute your randomized completely block design, RCBD. So this is the table you have been given to compute your RCBD. You have been given a hospital here as replication, and you have been given drugs here as treatment. Hospital as replication, drug as treatment. So now, how to compute this ANOVA table? Now, how to compute this data? You are going to take the sum of all your drugs. You are going to add 8, 11 and 14. If you add 8, 11 and 14, you are going to have 33. Then if you add 13, 15 and 17, you are going to have 45. Also, if you add 10, 16 and 17, you are going to have 43. You are going to have 43. Alright, so now also you have to find the solution, the sum of your replications. The first hospital here, you have 8, 13 and 10. So if you add all of that up, you are going to have 31. You have 31. So in the second replication, you have 11, 15 and 16. If you add that all up, you are going to have 42. You are going to have 42. So also in your third replication, you have 14, 17 and 17. And if you add all of that up, you are going to have 48. So now let's add all of these numbers, and this is going to give us the summation of y ij. If you add all of this up, this is going to give you 121. It's going to give you 121. I would love to make the whole of this bold. Alright, so we have this way. We have it this way. All of this is now bold. So now in computing our analysis of variance for randomized complete block design, let's now go back to our worksheet. In computing our analysis of variance for randomized completely block design, we are going to be needing some parameters here. We are going to be needing our, let me take it down. We are going to be needing our SS treatment. We are going to be needing SS treatment, and we are going to be needing SS total. We are going to be needing SS block. We're going to be doing SS error. So this is all for this is what we're going to be doing for the sum of squares. The sum of square, treatment, total, block and error. So now for mean square, we're going to be finding our MS block, mean square block. We're going to be finding our MS treatment, mean square treatment, and we're also going to be finding mean square error. So this is for mean square. Now we're also going to be, of course, be using our degree of freedoms. Alright, so let's go into this calculation more properly. So first of all, we'll be starting with our SS total. First of all, we'll be starting with SS total. So to calculate your SS total, the formula for that is going to be summation I from 1 to t summation j from 1 to b yi j squared minus bracket of summation I from 1 to t and summation j from 1 to b of y dot dot divided by bt, and this will be all squared. So this is your formula for SS total. So when we look at our table now, the first value to get here is our yij squared, y square ij rather. So to get that, what you have to do here on the table is that you do 8 squared plus 13 squared plus 10 squared plus 11 squared plus 15 squared plus 16 squared plus 14 squared plus 17 squared plus 17 squared. So that is what we are going to do to get that value. So let's do that and see. 8 squared plus this 8 squared plus 11 squared plus 14 squared plus dot dot dot, if you do that, plus the last value, which is 17 squared. This 17 squared, that is squared there. So this will be minus now this value here is what we have here, 121 squared divided by BD and BT, 121. This minus 121 squared divided by 9. BD is 9 because we have 3 replications and 3 blocks there, so we are going to have 9. So if you do this very well, you are going to have 1709 minus 1626.78, which is going to give you 82.22. So this is your SS total for the given data. So let's move to the next parameter here, which is our SS block, which is also the same thing as our SS hospital. So the formula for this is summation from J. This is dealing strictly with J. Summation from J 1 to B, then this will be y I dot squared all divided by B minus what we have here. This is going to be minus what we have here, and this I from 1 to T and J from 1 to B, y dot dot squared, all this square divided by BT is referred to as the CF. So instead of writing all of this, I'm going to write it as CF. So I guess you understand when you see this. So now this is going to be equal to SSB is going to be equal to, now let's look at our table for these values here. This is our block. This is our block here. We are dealing with our block here, and then I will know that our blocks are the hospital here. The hospital is our block. So we are going to be dealing with 31 square plus 42 square plus 48 square divided by 3 because we have 3 replications. So 31 square plus 42 square plus 43 square is going to divide by 3 is going to be our block. So let's look at that. I'm going to have 31 squared plus 42 squared plus 48 squared, 48 squared, all divided by 3 minus, so our CF here we already know it to be 1626.78. There's no need to still calculate this since we have it here. So this is going to give us, if we do this very well now, you are going to have 1676.33. So this is going to minus this 1626.78, and if you do that well, you are going to have 49.55. 49.55 is the value you are going to have. 49.55. So that's what we have. So quickly, let's go to our SS treatment. Let's go to our SS treatment, which is the same thing as SS jog. So the formula for this is going to be summation from I from 1 to t and y I dot squared divided by t minus cf. So let's look at our table to know how this is going to look like. So looking at our table, this is going to be the summation of 33, because this is our drug here is a treatment. So the summation of the columns is 33 squared plus 45 squared plus 43 squared divided by 4, because we have 4 treatment here. Divided by 3 because we have 3 treatment, which is 1, 2, 3. So you have 33 squared plus 45 squared plus 43 squared. 33 squared plus 45 squared. Plus 45 squared plus 43 squared divided by 3, because that's the number of treatment you have, 3 treatment. So this is going to be minus 1626.78. 126.78. So if you do that very well, if you do that correctly, you are going to have 165.4.33 minus 1626.78, which is going to give you 27.55. So this is your SS drug, which is also your SS treatment. So quickly, let's look at our SS error now. But SS error is going to be equal to SS total minus SS drug minus SS hospital. So our SS total is what the first value we got is 82.22 minus our SS drug, which is the last one we did, 27.55. So this is going to be minus our SS hospital, which is this 49.55. So we are subtracting this from this. So if we do all of those all together and we do it correctly, we are going to have 5.12. So this is our SS error. Our SS error is equal to 5.12. So this is it. So quickly now we are going to be looking at our mean square values. Our mean square value, we are going to be looking at mean square hospital. We are going to be looking at mean square drug. We are going to be looking at mean square error. So these are what we are going to be looking at. I will be looking at our degree of freedoms. We are going to make use of our degrees of freedoms here, and our degree of freedom for treatment degree of freedom for treatment is given as T minus 1, and our degree of freedom for block is given as B minus 1, and our degree of freedom for error is given as T minus 1, B minus 1, and our degree of freedom for total is given as BT minus 1. So that is what we have, is given as BT minus 1. So that's our degree of freedom for total. But then let's look at our mean square now. Let's look at our mean square. So we're going to be looking at mean square. First of all, let's look at mean square hospital. So if we do that very well, we are going to have 49.55 divided by B. We know B to be what? To be 3. So our B is 3, minus 1 is going to be 2. So now this is 55 here. Now 49.55 divided by 2 now is going to give us 24.78. 24.78, that's what we have. So quickly let's look at our MS drug now, which is going to be referring to the treatment. So this is SS drug divided by T minus 1. So let's do that. SS drug, we had our SS drug to be equal to 27.55. Now dividing it by 3 minus 1, which is 2, we are going to be having our SS drug to be 13.78. So this is our SS drug, 13.78. So quickly let's look at our MS error now. Let's look at our MS error. MS error is going to be SS error divided by SS what? Sorry. This is going to be SS error divided by T minus 1, and B minus 1. And our SS error was found to be 5.12. Now 5.12 is going to divide all of this. So T minus 1 is 2, B minus 1 is 2. 2 times 2 is going to give 4. So this is going to divide 4. So if we do that, we are going to have 1.28. 1.28 is our MS error. So these are our mean of square values. So quickly now we'll be looking at our F calculated. Now the calculated value of F is going to be equal to this. We are going to have two calculated value of L and F. First one is going to be with respect to mean square treatment, and the second one is going to be respect to mean square block. So for the mean square, F calculated 1 of mean square treatment now is going to divide the MS of error. It's going to divide the MS of error, and also the second one, the calculated 2 now, is going to be with respect to mean square block, which will divide mean square error. So the first one now, let's check the first one. Now we have our mean square treatment to be equal to 13.78. Now this will be dividing mean square error, and our mean square error is to be what? Is not to be 1.28. So if you divide these two now, what we are going to have here is 10.77. So let's look at the second one, the F car 2. Now our mean square block, we know it to be what? To be 24.78. 24.78, all divided by error, which is what? 1.28. So if we do that, we are going to have 19.78. 19.36. We're going to have 19.36. So those are the values we have now. Now let's look at our ANOVA table. Let's put all these values in our ANOVA table. So on our ANOVA table, the first column here, we are going to have our source of variance. Don't mind my line. We're going to have source of variance. Then the first one here is going to be in regards to treatment, which is also known as our drug in this case. The second one is going to be in respect to regards to block. The third one is to error, and the last one is total. So the first one here, what we are going to have is let's first of all look at our degree of freedom first. Let's go at degree of freedom. So our degree of freedom for treatment here, we'll had it to be 3 minus 2, that's t minus 1. T minus 1 is going to give you, and t is 3 minus 1 is going to give you 2. So we have 2 here. Also for block, we had it to be b minus 1, and of course b is 3, and 3 minus 1 is also going to give us 2. So for our error now is t minus 1 to the bracket of b minus 1. So this is 2, this is 2. 2 times 2 is going to give you 4. Now for total, we are going to add all of this together. So if you add this, we are going to have 8. So total, we have bt minus 1, and b is 3, t is 3. 3 times 3 is 9. 9 minus 1 will give you 8. So this is for total. So the next one we are going to see is our sum of square. Now let's look at our sum of square. We know our sum of square treatment, which is also the same thing as sum of square drug, to be equal to 27.55. So also our block now, we know our sum of square block to be equal to, which is the same as sum of square hospital, to be equal to 49.55. So for error now, we have sum of square error. We calculated it to be equal to 5 point what? Let me write this properly. We calculated it to be equal to 5.12. So now for total, now we are going to add all of this, but we don't need to do that because we have already calculated our total. And if we add it, it will still give you this value, 82.22. So that is our sum of square. So let's move to the next one, which is our mean square. Now mean square treatment, we have calculated that already. Our mean square treatment, which is also mean square drug, we have it to be 13.78. Also our mean square block, we had it to be 24.78, and also our mean square error, we had it to be 1.2. We had to be 1.28. So this is all the values that we have. Now for mean square, there's no need to do total. There's no need for mean square total. So now let's look at our F calculated now. F calculated. So the first F calculated, which is with respect to treatment, which was given as MS treatment all over MS error, which was given respect to MS treatment over MS error, we had it to be 10.77. So the one we're given for block, which is ms block all over ms error, will have to be 19.36. so these are our f calculated values. So now let's now compare it with our f tabulated value, which is given as this alpha comma f alpha comma t minus 1 comma t minus 1 into b minus 1. So this is what we have, where these are the degree of freedom, this degree of freedom for treatment and this degree of freedom for error. So, and this is in respect to our given confidence interval here. This is in respect to our given confidence interval. So let's check this now for the first value for this in respect to treatment. Now let's check this f, and this is our confidence if interval is 0.05 comma, and our treatment our degree of freedom respectively are 2.4. So if we check the tabulated value for 0.05 confidence interval for 2.4, you are going to have 6.94. This is what we are going to have. So if you check this now, you discover that this is the value for our f calculated. Now we can't do another one for like b minus 1. This in respect to treatment. We can't really do in respect to block, because this will give us the same value, because this is the block is also b minus t minus 1, and they are 3. So you are going to get the same value. So there's no need for that. So now let's look at this. Let's compare our calculated values. Let's compare our calculated values with our tabulated value. Now comparing these two, now you discover that these two calculated values are bigger than the tabulated value. So what we resolve here is that we reject the null hypothesis and accept the alternative hypothesis. We are going to reject the null hypothesis in this case because these two values here are bigger than the tabulated values. So in the case where the tabulated values are the calculated values are bigger than the tabulated values, you reject the null hypothesis and accept the alternative hypothesis. So in this case, we reject the null hypothesis and accept the alternative hypothesis. So thank you for watching through this video. Please, if you are so much in love with what we are doing here, please, I would like you to subscribe to this YouTube channel and hit the notification bell to get updated each time we upload a video. Thank you. And also don't forget, your comment in the comment section is very, very important. We want to know your recommendations. We want to know if you are actually following what we are doing, and if you want us to do any video on any subject at all, on any topic, please let us know. Thank you.